rate factor 2 one. I'll put it in the appropriate.
All right, notes open. Yeah, that was good. We are talking about waves. Right? What moves in waves? You learned something new yesterday. Circles. Anything that spins moves in waves. No, it doesn't. It moves in circles. But how did it start making sense? If it started making sense,
moving forward.
It's in cycles.
It's in cycles because it goes around and then it cycles around and it cycles around. And what was my example that started to make sense when we were talking about it being underground and above ground? Yeah, Ferris wheel. If you're in a car, you have to get on the ride at the bottom, right? There's not really exactly like ladders and platforms to let you get on the ride somewhere in the middle of the Ferris wheel ride, right? Usually you get in the bottom. And then what happens? You go up. So technically in a wave, as time passes, you're at the bottom, and then you travel up to wherever the middle of the Ferris wheel is, and then you go to the very top, and then you go to the middle, and then you go to the bottom. And then you go to the middle and the top and the middle and the bottom, and the middle and the top and the middle and the bottom, and the middle and the top and the middle and the bottom, until the ride's over, right? And then you get off in the bottom. Okay. As time moves, cyclic motion or rotational motion can look like a wave too. But what else looks like waves or moves in waves? Yes, sound. Yes, water. Yes, other things too. Long story short, waves are important. But the only type of math, or the type of math, can I say only? The main type of math that models waves are sines and cosines. So, not yesterday, when quite a few of you were absent, but the day before, we did a very, 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 very basic transformation. We said, okay, if these are the parent functions of sine and cosine, what happens if I multiply sine times 2? And what was the only change that happened?
Amplitude.
Amplitude. Everything got stretched. Instead of going up 1, negative 1, now everything went up 2, negative 2. But I was still able to start at 0, end at 2 pi. I was still able to section my graph off with every pi over 2, like the normal quadrants I'm used to. Pi over 2 pi, 3 pi over 2, 2 pi. I was able to go 1 quadrant up, 1 quadrant middle, 1 quadrant down, 1 quadrant undone. And then I could just keep on going and going and going. All I had to do was go up 2, down 2. But, what else did we see yesterday? What if there was a lot more wrong? What if there's a vertical shift? That's you. And Alex said, wait a minute, isn't that usually at the end? Yeah, kind of. But when we have a sine or cosine, we usually write that plus or minus stuff at the beginning so it doesn't get kind of like stuck or confused in the sine argument. So proper notation puts that vertical shift way out here in the front. Vertical shift, horizontal shift, there's a minus on the inside, vertical stretch, and then horizontal shrink. And we worked through on the video, oh my goodness, how do we figure out where this wave is? And they actually had it on their calculators if you guys watched the video. And I was like, great guys, you can see it, it's on your calculator before we do any work. And I was asking, where's this? Where's the beginning point? And they gave me a decimal, and I said, no, in radians. And I was like, oh. And I said, well, where's this? And they were able to find it on their calculator, and they were like, oh, here's the decimal. And I said, but what about radians? And they were like, oh. So, if the calculator can't find for us the radians, we have to find them for ourselves, and the way to find them for ourselves is using a procedure. Because these graphs are a bit harder than the other ones that we were transforming, like absolute value, or parabola, or cubic, or square root, or e to the x, or ln. Hey, dance moves. Anyway, coming back. Sine and cosine are up there too, but I don't think anyone can realistically do this. So, yeah. Anyway, maybe you can. Maybe you are. Try it out. Let me see if you can, because I'm really curious. But besides that, tangent, I can do tangent. That one's good. But you have to like have it be smooth, and my elbow is weak. Oh, great. Okay, so coming back. Don't tell Jaden that. I know, we got another cast on. Poor guy. He's having a rough day. 2 more weeks. We have this pattern, and if we took our equation from yesterday and if we put it in the pattern, wait a minute. Why are there all these dotted lines? I took you guys over here, and I showed you guys what I'm writing all my really cool calculus formulas on. What kind of chart is this? A good old-fashioned elementary handwriting chart. You had dotted lines back here to help you do letters and numbers, right? What are we going to use dotted lines to help us do now? So, we talked about all these clues. We talked about all these clues. Okay. Who is this guy?
Who's Joe?
The middle. He's the middle. He's the axis about which the wave, like when the water is still before it starts waving, or the middle of like the Ferris wheel. That's how I brought in the Ferris wheel. The sinusoidal axis, the axis of rotation, the middle. He's the vertical shadow. Amplitude, how high, how low, that comes next. And then, okay, then it's a little weird. It's like, yay, sinusoidal, yay, amplitude. Then we like skip over that guy and ignore him because we don't like him. We come over here to the initial point. Where do you start? And then how long do you take? The problem is B by himself doesn't mean much. 1 over B tells me what's happened to the normal 2 pi that used to be how long the wave took. B by himself doesn't really tell me much. Sometimes he can look inside, sometimes he can look outside. Yesterday I gave you this to begin with. We had to pull the 2 out. And when we factor, we divide. That's kind of where that dude's coming from. This guy by himself doesn't tell me much. 1 over him, 1/2 told me what happens to the 2 pi as far as a shrink or a stretch. Okay, if you were gone yesterday and you don't have notes, if I were you, I'd take a picture of this page because we're going to refer to some of these vocab and I'm going to be doing some of this work because we're just going to basically work on examples today. Today is a homework help day. Some of you have started it, some of you have not. But either way, I hope today is helpful. So maybe have this picture just kind of on your desk. You can be looking at it. If you don't have notes where you can just be looking above or looking on the page before. Are we good?
Yeah.
Ish? Okay, let's go play. So, amplitude. Amplitude. If you need to write it, you can write it. If you don't need to write it, it's okay. Amplitude is the how high, how low. And I've used it a couple times in class, like amping it up. Shout out to Alec. But also, for the rest of us, if you're amping it up, you're turning it up, right? Making the waves go higher, the sound go louder. But then you can also have the amplitude go lower also. So our handwriting lines will get more spread apart or closer together for the wave to get higher or lower. But amplitude is also known as half the distance. So if you did have your wave, and let's see, what wave am I modeling right now if I'm starting in the middle and ending in the middle? Sine, good. Sine. You can think of him, well, kind of awkward. Kind of think of him. He's like an S, but he's backwards. Like he's an S. Whereas cosine, if I can actually get him. Cosine, it's a C, right? That's a C, that's an S. I mean, not quite. Anyway. Amplitude is this distance. Does that make sense? It's how high, how low it goes. That's the amplitude. Period, how long? A period of time. Oh, okay. How long? I'm going to do a cosine curve this time, just because. Mind you that there are different ways of showing waves. From beginning to end. Wait a minute. Why did I write C over B as my starting point? Oh, I think that has something to do with that formula I just showed you. And why did I start with 2 pi for my period, my how long, how far? You can actually put how far. Sometimes that helps a little bit. The how long is just a way of remembering it, but how far is literally how we graph it. How far from beginning to end of one cycle. 2 pi, why am I judging based on 2 pi? That's the standard period of a sine or cosine. It takes 2 pi to complete one full rotation to complete. Oh, so wait, like the unit circle rotation-y thing and the wave thing, it actually does go together. The going around and the up and down. Huh. And why am I dividing by b and not multiplying by b? Because horizontal dilations are different than I think. I don't multiply by the factor, I divide by. The horizontal distance from beginning to end of one cycle. Let's see, any more vocab clue stuff? I mean, I did a really short, sweet there. The vocab clue stuff. Oh, translations. I have the vertical and the horizontal. The vertical shifts that middle line up or down. But there's not really like a snazzy name besides the sinusoidal axis that we already talked about. So, I don't know. He's a thing. He's going to be the middle of the handwriting lines. And guys, I don't make the top and bottom solid just because I want my wave to be the only solid part. He's the only actual part of the graph. Everything else is just kind of guidelines to help you get him. So I make the top and bottom dashed but longer just to be like, hey, top boundary, bottom boundary, middle boundary. And then the horizontal shift. This is the guy that gets a little bit funny. Well, period gets funny, and the horizontal shift or the phase shift, or you could also hear the word phase displacement because it's been displaced. You can also kind of hear it that way. That's where the initial point is, or where the beginning of the cycle is, or like over here where the first C over B was. Oh, that looks like an A. I'm sorry. Maybe it's just me, but that does not look like C over B. C. Okay. So a hint for that. A hint for that. For that little, where's that phase shift guy? Here he is. There we go. For a sine, because he starts in the middle, right? For a sine, his initial is going to be at, let's see, the x is the C over B. And he always starts in the middle, which if it gets shifted is going to be D. Some of you guys are memorizing people, so you're going to like to memorize where to put the first point. And for cosine, he doesn't start in the middle. He starts at the top. And so he's also going to start at C over B, but instead of starting in the middle on the sinusoidal axis, he's going to start on the middle up A. Unless he gets flipped. There could be something where we get a reflection and then everything gets turned upside down. Upside down of a cosine is, well, instead of like a cup, it's more like a mountain. And upside down of a sine is, instead of it going up before coming down, it's going to go down before coming up. But sine actually starts here no matter what. He just sometimes goes up and sometimes goes down if he's been reflected. And cosine, well, he won't start at the top. If he gets reflected, he'll start at the bottom. But anyway, that's just kind of some vocab. Going a little bit deeper in some of those clues that we did super fast yesterday. Sorry. Now it's time to practice. So, what if I give you all dual page? I see a few of you guys still writing. Oh, that's my summary page. Hold on. Wait. Let's get another example before we summarize everything. Hold on.
I figured something out, Steve.
There we go. You figured something out.
I
Good
figured
team.
out of phase means finally.
Oh, nice. There you go.
The sound got was very exciting.
That's kind of cool. Otherwise, probably the only other time that you refer phase is like moon phases, right? Or phases of the moon. Maybe you refer to that. Phase 1, phase 2. Wait a minute. Guys, there's not much going on here, right? Like, if I was to ask you, in words, what transformation occurred, what would you say? A shift? Horizontal, because it's on the inside, huh? Horizontal squished by 1/2? Sorry. Horizontal stretched by 2. What?
Oh, yeah.
It's backwards what you think. That division by 2 horizontally, remember everything on the inside, backwards of what I think. Ah, it's not being cut in half, it's being doubled. So why am I about to write 4 pi?
Because it's overshoots.
2 pi over 1/2.
Yeah, my horizontal dilation by 2 said instead of going 2 pi, it's going to go 4 pi. So question, where's the half point of my wave going to be? The whole thing finishes at 4 pi. Halfway is going to be 2 pi, quarter of the way is going to be, because remember I still need my 4 quadrants, my 4 phases, my 4 branches, at pi. Oh, so instead of going by half pies, I get to go by whole pies. But did anything change as far as it starting in the middle at 0 and going up 1, down 1? Nope. Just the whole horizontal thing. So the cool thing is I get to start at 0, and then I get to go up to 1, down to 0, down to -1. If I know how the normal sine curve works, this is actually really easy, and I don't need all those shortcuts. Wait, with the shortcuts it worked, though. Could I rewrite this only one transformation equation to show all 4 of those things that were on the screen a second ago? Y equals 0 plus 1 sine of 1/2 x minus. If I was to write it the long way, there's a D, there's an A, there's a B, there's an X, and there's a C over B. Does it match up with what I just graphed? Is my middle, is my sinusoidal axis at y equals 0? Got it. Is my amplitude, how high, how low? I'm amping it up just to go, oh, just 1? I could have gone up 1, down 1. Oh yeah, it's totally going to cycle in between there. Okay, cool. Could I have used this to find my, period, saying, hey, what happens to my period if I divide it by, ew, gross, if I divide it by 1/2 multiplied by the reciprocal? Instead of 1/2, it's really a 2. Hey, it's going to take 4 pi from the beginning and the end. Oh, wait, by the way, where's the beginning again? For sine, it's 0 and D. Beginning point, 0, 0. It takes 4 pi for it to finish. And then the only other like graphing clue is take that 4 pi, cut it into fourths, and say, what are my quadrants going to be? AKA, what are my quarter cycles going to be? Oh, every pi. Okay. 1 pi, 2 pi, 3 pi, 4 pi. Got it. Done. Dun, 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 dun. Yeah. But could you have just said horizontal dilation by 2 and then just made it go to 4 pi instead? Oh, so then why did you talk about all these complicated things? Why not just do normal transformation? Is there a bit more going on in this one? We've talked about 4 different transformations and mentioned that reflections might come back. My question to you is, how many changes have occurred on this guy? Careful, not 4. Oh, I guess you could say 4. Most of it. Out of the 4 that we were talking about, D, A, B, and C over B, it only has 3 of them, but it does have a negative, which means it's going to reflect. What's my sinusoidal axis if I'm supposed to start there? Look at your little formula. Isn't that the D guy? Who's the D guy? 0. Ah, 0. Why is it 0? No one's there. So you could think of it as 0 minus. Sometimes it's helpful to think of, oh, hey, why am I pulling the 2 pi out?
Because 2 pi
is my B. You see it? 2 pi is B, and so I need to pull him away to say, like, oh, he's my B. But when I pull him away, I have to remember factoring, we divide, right? So 2 pi is gone. And what's left? Okay, now I have all my pieces. Except I better make a note to myself that there's going to be a vertical flip. If I don't think about that minus sign, I might just totally forget that I'm supposed to vertically flip this cosine. Ugh. It's okay. It's okay. It's okay.
Oh,
What do we know?
You know D, and you know B, and you know B.
What do you think we should start with?
Wait, why do you know why is A for
A is not 0. A is 3. D is 0 because there's no addition or subtraction apart from my trig. There's multiplication, but there's no like +1 +2 or -2 plus or -3 plus. There's no addition or subtraction, no vertical shift.
So the amplitude.
Yes.
Oh.
But wait, what do I start with my graph? What do you guys want to start? Him, or the reflection? But amplitude, don't we have to go up and down from the middle? Uh-oh, so we better start not with the amplitude, but with the, who's the middle? Yeah, and who's D? Good, so I can start with, I need to know the middle before I can go up or down my amplitude, because if this ever shifted, I need to find the middle first and then go up and go down from wherever the middle is. Okay, so the middle is 0, so I have my SA at y equals 0. Middle line, check. Amplitude tells me to go up and down how high? Okay, so I'm going to go up 1, 2, 3, and go down 1, 2, 3. So I'm at 3 up here, and I'm at -3 down here. Sweet. So far, I've taken care of that guy, I've taken care of that guy. Now what? Okay, we could figure out the period. We could take this guy off to the side and say, hey, I need to use you. But careful. Remember how the period says 2 pi was changed how? This is a dilation. It's 1 over what I think it is. So it's 2 pi over b, or 2 pi times 1 over b. Wait a minute, that's weird. Doesn't that just go away and I just get 1? So it's only 1 long? Okay, sweet. 1 long. Start here, go to 1. Boop, boop, boop. Cosine. Dun, 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 boop.
Oh,
P.S. I'm very wrong. Maybe you shouldn't have copied what I just did.
okay.
How old is that too?
Yeah, I'm not sure of that.
I started him where he normally starts, at x equals 0, but what does the math say? So even though I know how long he's going to take from start to end, I can't use him until I figure out where he starts from. So where does he start from, guys? -2. Good. Remember, it's x minus whatever that horizontal shift is. So I have to start him way over here at -2. And why am I going to start him down here? His cosine is one of these guys, right? Normal cosine, but what happened to him? He has vertical flip because there's a negative on the outside of the trig. Well, wait a minute, hold on. So I just kind of randomly start putting points and say, yay, I'm done. Dun, 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 dun. Incorrect. Why?
Oh, sorry.
Or
How long is it supposed to take to do 1 cycle? 1. And how long did I just take? 1, 2, 3, 4. I just kept going. That doesn't work. It's supposed to finish in 1. It's supposed to finish in 1. Well, hold on. Doesn't that mean it's going to start and stop at... If it starts at -2, guys, and it's only taking 1 to complete.
Starts at -1.
Yeah. It's going to be done. It's going to be back here at -1. Well, then wait a minute. What am I going by if I need all 4 quadrants to fit between -2 and -1?
Just do -1.5.
Yeah. And 7.5 and -1.25, right? So I have to go from the bottom to the middle to the top to the middle to the bottom, all in 1, if you want to think about it, second. This got sped up too, not just amped up, but also sped up. So if I was to do like a few cycles, I'd actually have to keep on going and then come here and then come here and then come here and then come here. So if you were to graph this on your graphing calculator, he'd be all squished. Can I see it? He got horizontally shrunk, squished in. So we have our D plus or minus A, sine or cosine, B, x minus C over B, and, oh, isn't that the same thing? Oh, at least it's super similar. My advice to you is, if it doesn't have all 4 pieces, to rewrite it with whatever pieces it does have. This one has a D, this one has an A, this one has a cosine, this one has a B, but it doesn't have a, oh, just make it 0. If anything's ever missing, just make it a 0, or if a multiplication is missing, make it 1. Does that kind of make sense? You're going to make handwriting lines, you're going to make your ways. You got to know where to start it and how long to make it. Bye, guys. We'll be grading homework with the pretend me in the video tomorrow.
We can do the whole thing, or